Namaste students. We are going to start with the last topic of a permutation, that is circular permutation. As I mentioned in my previous video, circular permutation very easy, nothing new. Alright, new definitely in terms of circular permutation, but permutation you know how to solve it by now. Now it is, till now what we were doing is we were arranging it in a row. That was a linear permutation. Is it clear? Linear means when it is a straight line. Clear? Now instead of linear I have to arrange somebody. Suppose there is a meeting, a round table meeting. There is a meeting and there is a round table and 10 people have to be seated on that. Clear? Now when you enter in the room, this is a table and there are the chairs, seats are there, 1, 2, 3, 4, 5, 6, 8, 9, 10. Clear? So what happens? You go and then you say, I told you, okay, fine, somebody should go and sit on the first seat. Which is the first seat and which is the last seat? That's a problem. And when you were doing a linear permutation, if I say starting from the left, the extreme left is my row seat 1. This is my seat 1, then it is a seat 2, seat 3, seat 4. I can give a direction. Alright, this is the 10th seat. So I can give a direction which is starting from extreme left, that is seat 1, and the extreme right is the last seat. Clear? So there I can tell, everyone knows which is extreme left, which is extreme right. So very clear which is the first seat and which is the last seat. But when I talk about a circular arrangement, I can't say extreme left, extreme right, because there is nothing. Circle means from wherever it starts, it ends at the same place. So that's a problem. So what happens in such situations? When suppose 10 people have to be seated, so what will happen? The person who is going to head the meeting, I'll say, so the principal is going to take a meeting, so I'll fix principal's seat. I'm going to fix principal's seat. This is principal's seat. A person who is taking the meeting would sit here. So that's my first seat. Now I can say, okay, right to the principal, the vice principal will sit, the coordinators would sit, and followed by the different teachers. Or right, left on the principal, vice principal would sit, the coordinators would sit, and followed. That means एक person की seat fix कर दिया हमने. Clear? So बाकी how many people are left? Now 10 people are left. Sorry, 10 total were there. How many people are left? 9. अब 9 के लिए 9 seats हैं. अब fix हो गया. This is my first seat, second, third. तो कहीं पर भी जाके बैठ जाओ. So that means the principal will sit in one way. Remaining 9 people will sit in 9 factorial way. So that means 10 people can be seated on a round table in 1 into 9, 9 factorial. That means 10 were there, now it has come to 9 factorial, because whenever there is a circular arrangement, you have to fix a seat of one person which shows this is the starting or this is the ending, whatever the way it is given in the question. Is it clear? So 10 people can be arranged in 9 factorial ways. So if I generalize, in general, n objects can be arranged in which order? In circular arrangement. In n minus 1 factorial. Got it? Children, clear to everyone? n minus 1 factorial. Because एक person को तो मुझे fix करना है, जिसको fix किया उसको arrange करने का तो एक ही तरीका है. बाकी बचे 9 को arrange करने का there is a 9 factorial ways. Is it clear? Alright, this is a 9 factorial ways. Clear? As I was telling you here, what did I say? If I say extreme towards when the principal is sitting, towards right, the vice principal coordinators, this is the arrangement, that means this is which? If I talk about this way, so this is my anti-clockwise arrangement. And if I say go this way, that is my clockwise arrangement. And दोनों arrangement definitely it makes a difference. When I say In the principal towards right, the vice principal is sitting, towards that the music teacher is sitting. So that is arrangement is different. And if I say left and right, the vice principal should come here. So the person who was on left will become on right, right will become left. That means that makes a difference. That's a different arrangement. Is it clear? That's a different arrangement. So when clockwise and anti-clockwise makes a difference, the total arrangement of n objects in a circular way would be n minus 1 factorial. In n minus 1 factorial. Is it clear? Put a note. When this anti-clockwise and clockwise cannot be distinguished. Here anti-clockwise and clockwise can be distinguished. Here towards right, the vice principal is sitting, that side music teacher. If I change towards left, vice principal is sitting, towards right, the vice principal, towards left, the music teacher. So both the arrangements are different. Is it clear? That makes a difference, anti-clockwise and clockwise. But if it happens that the clockwise and anti-clockwise cannot be distinguished. Suppose I am making a garland using different color flowers. When you make a garland using different color flowers, can you distinguish towards end key what was the first one? Is it clear? So you have a different, you see from clockwise or you see from anti-clockwise, it cannot be. So in that case you are making, or you say you are making a necklace using different color beads. If you see the necklace towards end, it is all fine. You see from clockwise or anti-clockwise. In that case, when I can't distinguish left and right, anti-clockwise and clockwise direction, the number of arrangements of n objects, definitely we are doing circular permutation, of n objects in the circular arrangement, circular permutation would be half of n minus 1 factorial. Half of n minus 1 factorial. It was n minus 1 factorial when it does make a difference ki who's sitting on the left, who's sitting on the right. Is it clear? When it does not make any difference ki ultimately, finally, when you see a garland, when you see a necklace, it seems to be the same. Is it clear? Then it will be half of those arrangements. Half of n minus 1 factorial. Because here I am considering clockwise also and I am considering anti-clockwise also. And here doesn't matter, I can't distinguish between these two, so that's why it will be half n minus 1 factorial. Again children, whenever you have to arrange somebody on a circular table or something, so what do you have to do? You have to fix one person, then you have to arrange the remaining people, and they may give you some conditions that somebody should sit here, 2 women should not be together, 2 men should not be together, this girl and that girl should not be together. Fine. So those conditions will be considered later, but then you have to fix up one person, then only you can proceed in this kind of questions. Let's see the examples so that the things will be more clear. The first is, in how many ways can 6 persons be seated in a line and in a round table? In a line, 1, 2, 3, 4, 5, 6. No restriction, first person can 6. All first seat has all 6 choices. 6, 6, 6, 6, 6, 6. Yes? No. In how many ways 6 persons can be seated in a line? So first seat can be occupied by 6 people. 1 seat is filled, then 5, then the next one, the next one, the next one, the other way around. Is it clear? That means the first person enters, he has all 6 choices. The second person enters, he has 5 choices. The other person enters, he has 4 choices now. The other person enters, he has 3 choices too. So that means it will be 6 factorial. Is it clear? That means I have 6 people, 6 seats, so that is 6p, 6, that is 6 factorial. Is it clear? You can't say that 6, 6, 6, 6, 6. अब एक person बैठ गया तो सीट तो ऑक्यूपाई हो गई है. That means अगले person के लिए कितनी choices रहेगी? 5. अब 2 persons बैठ गए हैं तो अगले person के लिए कितनी choices रहेगी? 4, 3, 2, 1. So it will be 6 factorial, 6p, 6. Alright, now at a round table. So I told you we have a formula also, but round table we have to fix one person. So that means one person, the person 1 has been fixed here. The person has been fixed here. So isko arrange karne ka to way it will be only 1. Now the remaining 1, 2, 3, 4, 5, they can sit on any seat. Is it clear? That will be 5 factorial. Alright, 6 factorial. So that means all I can say, because 5 persons are there, circular arrangement. Of 5 persons be 5 minus 1. Fine, that is, okay, 6 persons were there, 6 minus 1, 5 factorial, and that is 120. So you can do by the formula also. N persons can be arranged on a round table with the formula n minus 1 factorial. So I had 6 persons, they can arrange on the round table in 6 minus 1, that means 5 factorial. Clear? Now coming to the next one. In how many ways 5 ladies and 5 gentlemen be seated at a round table so that no 2 ladies are together? No 2 ladies are sitting together. I have 10 seats. 1, 2, 3, 4, 5, 6, 7, 8, say 9 and 10. Clear? This is ladies should not sit together. So that means if ladies should not sit together, I have 10 seats and 10 people are there. So that means first of all, let's adjust the male members. And then 2 ladies, between 2 male members, 1 lady can sit so that no 2 ladies are together. So but it is a round table. If I am picking up the men, arrangement of 5 men on a round table. How? First of all, the men are going to come and sit because they have to keep a gap in between for the ladies. Alright, so first of all, the men 1 has to be fixed. Men 1 has to be fixed. Ab yahan se pata chal gaya ki this is the men 1. So definitely men 2 is going to be here or here or here. So 1 is fixed, 1, 2, 3, 4. These all 4 men can interchange their positions. There is no problem. As it is, we know that if 5 men are to be arranged on a circular table, so it will be 5 minus 1 factorial, that will be 4 factorial, and that is clear. Alright, so 4 factorial here. Clear. Now for men are adjusted. Now coming to women. So I have 5 places. Now as the seats are clear, so women can come here, sit. Women can come sit here. Women can come here. Women can come here. There is no problem. Women can come and sit anywhere. Alright? Clear? Fine. So now for women there is no restriction. The seat was already fixed. Men, they have decided the seats. They are sitting on the seats. So women can come and occupy any 5 places. So arrangement of women. No restriction on given. 5 women, 5 seats. So that will be 5 factorial. Alright, this is 24. This is 120. So total number of such arrangements possible where 2 women cannot sit together. Alright, that will be 120 into 24. I hope it's clear to everyone. Alright, so first of all, this is women should not sit together. So you fix the male members. Alright, first of all, fix male members so that, and it is a round table arrangement. So first of all, you have to fix a seat of 1 person so that then you know which is the next seat, and accordingly we can arrange the other people on this round table. Okay, look at the next one. If there are 3 boys and 3 girls, they have to be arranged on a round table. The 3 boys and 3 girls have to be arranged on a round table. Alright. It says what is the condition given? There is a one boy X who does not want any girl neighbor. That means the girl should not sit near to that boy. And there is a girl Y who does not need any boy neighbor. So that means this problem is with this boy X and girl Y. So wherever is the problem, wherever is the restriction I told you earlier, fix their seats. Let the boy X is arranged here and girl Y is arranged here. Clear? Now there were 3 girls and 3 boys. Out of this, 1 boy is fixed and the 1 girl is fixed. Now they are neighbors. There are 6. So that means 4 seats remaining. Now this boy X should not have any girl. So 1 girl is already fixed. So he does not want any girl. So that means here it has to be boy only. Boy 1, boy 2 is left. And this Y does not need any boy neighbor. So it has to be, these seats have to be occupied by girls only. Clear? It has to be occupied by girls only, because this X does not want any girl here. This Y does not want any boy here. So total number of arrangements possible. अब सबका एक एक करके लिखते हैं, otherwise we can directly write, but I'll write everyone's. Boy X is arranged, so boy X can be arranged in one way. Girl Y was arranged, that girl can be arranged in one way, because हम लोगों ने उनकी सीट फिक्स कर दी है कि तुम वहीं बैठोगे, तुम वहीं बैठोगे, तो उनका अरेंज करने का एक ही तरीका है. But now, boy 1 and boy 2 has an option. They can switch. Boy 1 can go there, boy 2 can come this side, boy 2 can. So 2 seats and 2 options. So boy 2, 1 can be arranged in 2 vectorial ways, because I have 2 seats, seat 1, seat 2, and 2 options, 2 people for that, 2p2, or you say 2 factorial. Girl 1 and girl 2 also have an option. They can also switch. Girl 1 can go that side, girl 2 can come this side. So again 2 factorial. So 2 factorial into 2 factorial. There are total 4 such arrangements possible where they should be seated in this way. Is it clear to everyone? Just pick up the last example. Now suppose I have 5 beads of different colors. 5 beads of different colors. Five beads of different color. I have to make a necklace out of it. I have to make a necklace. In how many ways can 5 beads of different colors form a necklace? अब 5 beads का necklace बनाना है, तो I told you when we were doing the basics, when you make necklace, garland with the flowers or the beads, anti-clockwise and clockwise arrangement cannot be distinguished. Clear? उनको हम अलग-अलग नहीं कर सकते. एक ही जैसा लगता है. You have seen necklaces, you have seen garlands, ठीक है? I can't distinguish कि clockwise direction है या anti-clockwise direction है. So what is the formula? We have done the formula. So total number of arrangements or necklaces possible would be 1 by 2. What is the formula? N minus 1 factorial. So 1 by 2, 5 minus 1, 4 factorial. So 1 by 2 into 24. So 12. That means with 5 different colored beads, how many total number of arrangements are possible? Those are 12. Is it clear? So this was all about your circular permutation, though this topic is not there in NCERT, but I told you in the beginning, because permutation combination is such a topic, I can't differentiate. This is NCERT, now let's do the next one. You have to practice so many questions because topic is such. Sometimes you get confused also. Alright, so this we have finished today, permutation. So next what we will be starting with, that would be the combinations. If you know the name of the chapters, permutation and combinations, we have finished permutations. We will be starting with combinations now.